Hello, my name is Lauri Malmi. I'm presenting you our paper Theories and Models of Emotions, Attitudes and Self-Efficacy in the Context of Program Education, co-authored with Judy Sheard, Päivi Kinnunen, Simon and Jane Sinclair. The background for our work stems from the need to develop better theoretical frameworks for our research field. 2 years ago, Nelson and Co. in ICER made a claim that we should invest significant resources in building domain-specific theories and measures of those effects, especially computing knowledge, so that we may use them as indicators of progress. Moreover, in EDC Working Group report from last year, which surveyed literature of introductory program research, they claimed that there are very few publications focusing on the student experience, and noted that this is an important area that appears to be underexplored, and we feel that the community would benefit from further work in this area. There are a couple of papers which have focused on analyzing the using theory in computing education research. For example, what theories have been used in our field and from which disciplines they originate? What is the role of theories in computing education research, covering also their positive and negative aspects in research? What domain-specific theories have been developed in computing education research? Or what instruments have been used in our field? And finally, how learning theories are adapted in our field. To augment this work, we set up our research questions as follows. What theoretical constructs, including instruments, have been developed in computing education research that address emotions, affects, attitudes, beliefs, or self-efficacy in teaching and learning programming? And where have they been published? How have these constructs been developed? What types of constructs have been developed? And finally, how have they been used to inform further research? So our question was how to identify theoretical constructs. This is not obvious because there is no generally agreed definition of what is a theory, a model, a framework, or some other term that is used. We adopted therefore a rather loose than a strict definition, something that is developed through application of some rigorous empirical or theoretical approach, such as statistical models like regression, path analysis, factor analysis, or qualitative constructs like grounded theories, phenomenographical outcome spaces, or taxonomies, typologies, or validated instruments. We selected our data pool to include first all full papers published during the last 4 years in ICER, Computer Science Education Journal, and ACM TOS. We had already in our previous work analyzed 6 earlier years, from 2010 till 2015. Then we decided to add one conference, Learning Analytics and Knowledge Conference, starting from 2011. Moreover, to explore what is available in other journals, we used the Scopus database to carry out a wide search among journals in engineering, computing and psychology. In total, we identified over 3,000 initial papers which might include something relevant for us. Out of these, after rapid screening, we identified 252 papers which were detailed screened in our analysis. So how did we do it? There was first independent analysis by 2 or 3 people, followed by a joint discussion to reach consensus on what was actually counted as a theoretical construct in the paper. And there we identified in total 50 source papers. And for these source papers, 2 researchers analyzed together to reach consensus on that whether the presented construct was original work and fell in the computing education research domain, or was it a new instrument. And what aspects were concerned in this construct, and what methodological approach had been used to developing it. The 50 constructs, out of these, 17 were published in ISER, LAC, Computer Science Education, and TOES. And 2/3, 33, were published elsewhere. In some of the journals that were no surprise to us, like Computer Science Education, Educational Computer Research, and so on. But they had also been published in 21 other journals from quite different venues. The main focus areas of this construct were attitudes, emotions, and self-efficacy, while beliefs and affects were less covered. However, many papers covered 2 or 3 of these aspects. The most common development approaches that were used had been regression, path analysis, various forms of factor analysis, structural equation modeling, but there were also qualitative approaches like grounded theories, thematic analysis, content analysis. However, quantitative models were clearly dominated in our findings. Couple of examples what we found. We found in total 11 instruments that had been presented as new instruments. Some of them concerned attitudes, some concerned self-efficacy, either in university level or in primary school level, or students' self-beliefs within introductory programming context. Have a look at the paper to find out more about these. An example of a model, a quantitative model, is a path analysis model which shows that self-efficacy, perceived engagement, and perceived difficulty are significant predictors of students' final performance in Computer Science 1. Or a regression model which indicates that achievement in computer programming courses, computer programming self-efficacy, and perceived learning were significant predictors of attitudes towards computer programming among pre-service computer science teachers. Here is a model of influence of various factors on programming working styles. There are a lot of details in these models, and I'm not going to cover these in this presentation. You can have a look at the papers and the actual references. An example of qualitative models is a descriptive model of how computer science majors build self-efficacy perceptions carried out by Kinnunen and Simon. They reported 4 narratives that present either positive or negative development in students' self-efficacy. While the previous one focused mainly on introductory programming level, there were also interesting and relevant work which focuses on advanced programming, like this grounded explanatory theory of the impact of affects on software development performance, and how various events can trigger either positive or negative affects, which finally influence the focus of work and performance. Our next phase in our analysis focused on how the theoretical concepts had been used to inform further research. Therefore, for each source paper, we performed a Google Scholar search to identify papers which cited the source paper. We called these papers citation papers. We identified over 860 citation papers, but we excluded papers written in other languages, also papers which included very many citations. Then we focused on the recent years. In our analysis, we focused on finding in the paper how the source paper or its theoretical construct were presented in the paper, and we built with inductive content analysis a categorization how the theoretical constructs were used in the citation papers. Here's the categorization. Some of the work focuses on just describing the work very briefly or in a more elaborated way. Then there were papers which applied the construct in some way, and there were papers where the construct was used to extend or develop some new construct. And there were papers which tried to validate the construct in some way. So what did we find out? 90% of the citation papers did not use the construct from the corresponding source papers. But this is no surprise, because of course there are many other reasons to cite a paper than the theoretical construct that has been presented in it. 8% reported an application of the construct, and only 3% reported constructing something new, and 2% validating the construct. The most often reported use case was using an instrument. Our main conclusions thus are that there is growing interest in building domain-specific theories concerning these aspects: emotions, attitudes, affect, self-efficacy, beliefs in program education. And only 1/3 of the identified constructs were published in these venues where we expected to find them most, like ISER, LAC, CSED and TOES. Very clearly, the dominant approach in developing these constructs had been quantitative. And several new instruments had been created, and many of them had been used to inform further research, also building or developing new instruments. And while most works focused on introductory programming, there was significant work carried out in modeling large-scale program education. So, finally, we could summarize that there is evidence that computer education research is maturing as a research discipline, because it not only applies theories from other fields, but builds its own theories to explain learning programming. Thank you.